I don't get Trigo. How can I solve these word problems?
Shilo-san, we can search it on the internet.
Worry not, because we, math wizards, are here to guide you.
Angles and sides of a right triangle can be solved using trigonometric ratios and the Pythagorean theorem. Trigonometry can be defined as calculations with triangles involved in the study of lengths, heights, and angles.
Trigonometry and its functions have a vast number of uses in our daily life that is vital. In this video, we will show you how to use the trigonometric ratios and Pythagorean theorem in solving for the sides of a right triangle.
Triangle ABC with right angle at C. A is equals to 72 degrees and B is equals to 8 inches. What is the measure of each missing parts?
First, we're going to illustrate the given problem and solve for what is missing. Since angle C is a right triangle, therefore it measures 90 degrees. Angle A measures 72 degrees, and line B is 8 inches. The missing parts are angle B, lines A and C. To get the measurement of angle B, measurement of angle B is equals to 90 degrees minus measurement of angle A. 90 degrees minus 72 degrees is equals to 18 degrees. So the measurement of angle B is 18 degrees. To solve for line B, we have SOHCAHTOA, the trigonometric functions used as a guide, and we will use the trigonometric function tangent in solving line A. Tangent theta is equals to opposite over adjacent. Tangent 72 is equals to A over 8. To cancel out 8, we will multiply it by 8 in both sides. 8 times tangent of 72 equals A over 8 times 8. Cancel. Therefore, A is equals to 8 tangent of 72 degrees. A is equals to 24.62 inches. To solve for line C, we will use the trigonometric function cosine. Cosine theta is equals to adjacent over hypotenuse. Cosine 72 is equals to 8 over C. Cross multiply to get 8 is equals to C cosine 72. Divided to cosine 72 to get C is equals to 8 over cosine 72. C is equals to 25.89 inches. Therefore, angle B is equals to 18 degrees. Line A is equals to 24.62 inches. And line B is equals to 25.89 inches.
A woman climbs an 8-meter ladder that leans against the wall of a building. If the foot of the ladder makes an angle of 68 degrees with the ground, how far is the base of the ladder from the wall? So as you can see here, I already drew the angle of 68 degrees. And so following on, we know that the ladder is 8 meters. So here we have to write 8 meters around here. Now the question here asked is, how far is the base of the ladder, which is this part here, to the wall, which is this? So now, we now make this line our x, to which we have to use the formula cos theta equals A over H. You get that? Now, we have to go with this formula. Since we already knew what our cos is, we also know what our 8 is. So, it's now 8 cos 68 degrees equals x over 8. So now, multiply that by 8. So then, we cross them out to make them 1, both. So now all we have here is 8 cos 68 equals x. To which, if we grab our calculator, we can now get an answer of x equals 2.99 meters. Now, there's another way we can do this, is that we can also simplify this. So now we can also turn it to x, when simplified, equals 3 meters. So that is the answer.
So now we have for our second problem. The manager's table is 1 meter high. A CCTV camera is mounted on a wall 3 meters above the bank manager's table. It is used to view the bank's entrance door, which has a horizontal distance of 10 meters from the camera. What is now the angle of depression from the camera lens to the base of the entrance door?
So we now have the illustration. We have 4 meters and 10 meters. So this is the horizontal distance from the manager's table, the door, and the CCTV. So the door to the CCTV is 10 meters. So we can assume that this is also from the door to the manager's table. So we are missing the angle. So we have here the manager's table, 1 meter, and the 3 meters above it is the CCTV, so that is 4 meters. So now we have the two given, the 4 meters and 10 meters. So we can solve for the angle using the SOHCAHTOA, which we are all familiar with, I believe. So we are missing the angle, so we are given the opposite, which is 10 meters, since it is opposite to the angle, and this is the longest, so this is the hypotenuse, so this is the adjacent. So we have our A is 4 meters. So we can use this TOA because we are missing the angle, so we can use this to find the angle, and since we are given the opposite and the adjacent, so we have the tangent theta over opposite over adjacent, so we can substitute 10 meters in the opposite and 4 meters in the adjacent, so tangent theta. So we can solve this by eliminating the tangent on this side, transfer it to this side. So theta is equal to tangent times 10 over 4. So we can input that in the calculator, and we have tangent is equal to 68.20. So this is our theta. This is the measurement here in this side. This is 68.20 degrees. So this is actually not the angle that we are looking for. According to the problem, it is looking for the angle of depression. So this is just not the angle that we are looking for. This is where the angle of depression should be, where our x should be according to the problem. So we have this two. We can see that it forms a right angle when added, so which means it equals to 90 degrees. So we can see that we can find the missing angle by subtracting 90 degrees with 68.20 degrees. So we have 90 degrees minus 68.20 degrees, which equates to, we have the angle of depression is now 21.8 degrees or 21.80 degrees. So our x and the answer to our problem is actually 21.8 degrees. This is the angle of depression.
A radio tower is already old and is not safe anymore. Consequently, it must be braced with a cable whose one end tied at a point 20 meters above the level ground and the other end tied 6 meters away from the base to make it stronger. At least, how many meters of cable are needed?
As stated in the problem, a cable is tied 20 meters above the ground and the other end is tied 6 meters away from the base. The ask is, how many meters of cable are needed? In this given problem, the theorem that we will use is Pythagorean Theorem. We can only use Pythagorean Theorem if it's right triangle. Pythagorean Theorem states that the sum of the squares of the two legs of a right triangle is equal to the square of its hypotenuse, or a squared plus b squared equals c squared. Now we assign measurements to a variable. A equals 6 meters, b equals 20 meters, and c equals x. Then we substitute. A squared becomes 6 squared plus b squared becomes 20 squared equals c squared becomes x squared. Then simplify. 6 squared equals 36 plus 20 squared equals 400 equals x squared. 36 plus 400 is 436. Then find the positive roots of both sides and you will get 2 square root of 109 equals x. Since we are dealing with measurements, we find the decimal form of 2 square root of 109. The decimal form of 2 square root of 109 is approximately 20.88 meters. Therefore, the final answer of the given problem is 20.88 meters of cable are needed.
The problem that we will be solving is a triangle ABC with right angle at C, side A 6 centimeters and side B is equals to 10 centimeters. What are the measures of the unknown parts?
In accordance with the given, here is the right triangle. We know this is a right triangle because the angles are perpendicular to each other, and then the side A measures 6 centimeters, the side B measures 10 centimeters. First, we need to solve for angle A. This is the angle A. So to solve for angle A, we can use the TOA method, and then we'll use the TOA because the opposite and adjacent sides are given. So it'll be tan angle A is equals to our opposite over adjacent. Input the values. Our values for the opposite, this is the angle A, so the opposite side is 6 centimeters opposite, and then the adjacent will be 10 centimeters. So opposite is 6, adjacent is 10. Now in order to solve this, we need to transpose the tan here so that only the angle A remains at this side, at the left hand side. So angle A is equals to, if we transpose the tan, it will become into an arc tangent or tan with a minus sign. And then 6 over 10. Input that into the calculator. 6 over 10. The result will be 30, angle A is equals to 30.96, rounded off at the nearest 2 decimal places. Now we just have to input the measurement of angle A, which is 30.96 degrees. Here, 30.96 degrees. The next measurement we have to solve is for the hypotenuse or the side C. We can use two methods for solving side C. So the first method, we can use the Ka with regards to the angle A. So and then the adjacent of angle A is 10 centimeters. We can use the saw, but we don't have the measurement for angle B yet. So by solving Ka, cosine of 30.96 degrees is equal to the adjacent over hypotenuse. And then we input the value of the adjacent, again the adjacent of cosine 30.96 is the 10 centimeters. So 10 over h. Okay. Now perform the cross multiplication. And it'll be cos sine 30.96 degrees times hypotenuse is equals to 10. We just have to divide it by the cosine so that we can cross out cosine, and then the remaining variable will be the hypotenuse. And divide this side as well with the cosine 30.96 degrees. Input that into the calculator. 10 over cosine 30.96. The result is 11.66, rounded off at the nearest 2 decimal places. Centimeters, because it is a side. Now, this is the first method. This is the result. To the second method, this is quite simple. We just have to use the Pythagorean Theorem, which is c squared is equals to a squared plus b squared. C squared. We already have the value for a and b, which is a is 6, b is equals to 10. So a, 6 squared plus b, 10 squared. Calculate 36 plus 100. And then it will be 136. C squared. To get the square root of 136, input that into the calculator. Square root of 136. It's 11.66. Cancel this out. It's 11.66, rounded off at the nearest 2 decimal places. So this is the other way of solving for side C. Now we just have to input the value of side C, which is 11.66 centimeters. All that's left to solve is angle B. Now to solve for angle B, there are 2 methods or ways to get the answer. First is the same as getting the angle A, which involves the tangent over is equals to opposite over adjacent. So tangent of angle B is equals to the opposite of angle B is 10, and then the adjacent is 6.
So opposite 10, adjacent 6. Transpose the tan again. Angle B is equals to arctangent 10 over 6. Input that into the calculator. 10 over 6. And then the resulting answer will be 59.04, rounded off at the nearest two decimal places. Therefore, angle B is equals to 59.04. Now, for the second way, we just have to use the subtraction. In a right triangle, the overall measurement is 180 degrees. We already have 90 degrees in angle C. Therefore, we need another 90 degrees from both angles, meaning angle A plus angle B is equals to 90 degrees. To solve for angle B, just have to transpose angle A. So angle B is equals to 90 degrees minus, and then our angle A, the value of angle A, 30.96 degrees. Input that into the calculator. 90 minus 30.96. The result is angle B is equals to 59.04. Therefore, our angle B is 59.04 degrees. You can choose either of this method. Input the value. Now to input the value of angle B, 59.04 degrees. So now we have a complete right triangle with their values or measurements.
Oh. Oh, so that's how you do it.